Hello everyone, welcome back to our channel Problematical. We were discussing 2.5 exercise from class 9th Maths NCERT, chapter Polynomials. We completed till question 8. Let's continue with question 9. Question 9 asks you to verify these two expressions, these two equations. Now, there are two approaches to it. Let's see both in the first question and only one out of these two in the second question. In your first question, your LHS is equals to x cubed plus y cubed. Your RHS is equals to x plus y into x square minus xy plus y square. So, the first approach that you can take is solve RHS and come up with LHS. Solving RHS means multiplying the two brackets. X into x square is x cubed minus x into xy, x square y, plus xy square plus x square y minus xy square plus y cube. This term gets cancelled with this term gets cancelled with this term. You're left with x cube plus y cube. Another approach you can take for the same problem is observe these terms. Your LHS is x cube plus y cube. Now you know a formula of x plus y whole cube where you encounter these x cube plus y cube on the right hand side. Now let's expand x plus y whole cube. It gives x cube plus 3x square y plus 3xy square plus y cube. Which means you have an x cube plus y cube over here. Now, how can you use that? You can take these two terms on the left hand side. So you have x plus y whole cube minus 3x square y minus 3xy square is equals to x cube plus y cube. Now if you see, observe, you can take common out of the last two terms on the left hand side. So your first term remains as it is. From these two terms, you've taken minus 3xy common. You're left with x plus y is equals to x cube plus y cube. Now here on the left hand side, you have two terms, first term and second. Out of these two terms, x plus y is common. So you can take x plus y common outside. From the first term, you're left with x plus y whole square minus 3xy from the second term, bracket closed, is equals to x cube plus y cube. Expanding x plus y whole square, you have x plus y first, bracket as it is, x square plus 2xy plus y square minus 3xy is equals to x cube plus y cube. So here you have x plus y into x square. Now this plus 2xy and minus 3xy, these two merge together to form minus xy plus y square is equals to x cube plus y cube, which is your required answer, hence proved. Now since the section in this chapter is based on algebraic identities, the second proof is much more encouraged than the first one. So this is encouraged. This is also another way that you can approach the same question. Second part of this is x cube minus y cube is equals to x minus y, x square plus xy plus y square. Now, of course, you can take the first approach of multiplying the RHS and coming to LHS, but we will follow the second approach, the identity one. Now, we know the identity of x minus y whole cube because this your LHS, x cube minus y cube, are two terms from the right hand side of this identity, x minus y whole cube. X minus y whole cube can be written as x cube minus 3x. Let's write the shortened formula, minus 3xy, x minus y minus y cube. So we'll take this term on the left hand side because we need x cube minus y cube on one side. Well, LHS becomes x minus y whole cube plus 3xy, x minus y is equals to x cube minus y cube. from the this is your first term, second term, x minus y is common from both the terms, and you're left with x minus y whole square plus 3xy is equals to x cube minus y cube. X minus y into x, you're expanding x minus y whole square, a minus b whole square is b square minus 2ab plus b square plus 3xy equals to x cube minus y cube. This term merging with this term, you have x minus y, x square plus xy plus y square is equals to x cube minus y cube. Hence proved. Next question. 10th. Factorize each of the following. So first value is 27 y cube plus 125 z cube. Now here it can be written as 27 is 3 cube. So 3 cube y cube plus 5 cube z cube, since 5 cube is equals to 125. This can be combinedly written as 3y whole cube plus 5z whole cube. This looks something like a cube plus b cube, which and its formula we just saw in the previous question. Let's write the formula. We have a cube plus b cube is equals to, it should be considered as a formula and memorized as a formula, a plus b into a square minus ab plus b square. Applying this over here, we get 3y plus 5z as it is 3y whole square minus 5z into 3y plus 5z whole square. Close. Solving this further, 3y plus 5z in one bracket, 9y square minus 3 into 5 is 15 yz plus 25 z square. Factorizes to reduce the given equation into multiplication of two expressions. So here this is split into two factors, first factor and second factor, both in individual brackets. Next question, the second part of the same question. Factorize 64m cube minus 343n cube. 64, as you know, is 4 cube m cube minus 343 is 7 cube n cube. Cubes are to be memorized till at least 12. 4m whole cube minus 7n whole cube. This is 4m minus 7n whole cube. Sorry, you're factorizing, so you're applying the formula, the same formula. No, it's minus, so let's rewrite the formula. You're not using the same formula. You're using this formula for a cube minus b cube, which is your second formula or second equation from the previous question. A cube minus b cube is equals to a minus b into a square plus ab plus b square. This becomes 4m minus 7n into 4m whole square plus 7n into 4m plus 7n whole square. This is equals to 4m minus 7n into 16m square plus 28mn plus 49n square. So this is your first factors, these are your second factors. Next question. Factorize 27x cube plus y cube plus z cube minus 9xyz. Now, we have an identity for this, which is a cube plus b cube plus c cube minus 3xyz is equals to a square plus b square plus c square minus xy, sorry, ab, we are going with ab, minus ab minus bc minus ca. So here you have four terms. These terms can be split into this part. This is your first bracket, and your second bracket says a plus b plus c. So these four terms can be split into two parts, first part and second part. Let's try and see what the question looks like. You have to factorize this. That means your left hand side looks something like this. You have four terms and factorize this to get these two brackets. Let's correlate your left hand side with the formula. 27x cube in place of a cube means you have to represent 27x cube in terms of a cube. 27x cube plus y cube plus z cube minus 9xyz can be written as 27 is 3 cube, so it is 3x whole cube plus y cube plus z cube minus. Now you have to represent this in terms of 3xyz. Now y is b, 3abc. You have to represent this in terms of 3abc. If you correlate these two, your a is equals to 3x, your b is equals to y, and your c is equals to z. So putting these or trying to come up with 3abc over here, z is c. So c is taken care of. B is y. Okay. A is 3x. So you should split this 9 into two parts. So 3 into 3x can be taken y into z. Now this looks like 3 times a, b, c. So if you have the LHS exactly as the LHS of your formula, your answer can be replaced in terms of RHS. Now substituting a, b, c over here, because these terms is equals to your right hand side. You have a square. A square is 3x whole square plus b square is y square plus c square is z square minus ab, 3x into y minus bc, y into z minus ca, z into 3x. This is your first factor. Your second factor is 3x plus y plus z, which is a plus b plus c. This is equals to 9x square plus y square plus z square minus 3xy minus yz minus 3xz in one bracket, and in second bracket 3x plus y plus z. You cannot solve this question any further, so these are the two required factors. Now, next question. Here you have to verify whether your LHS is equals to RHS. Now again using the same formula, let's write the formula. Formula says a cube plus b cube plus c cube minus 3xy, again ABC, 3ABC is equals to a square plus b square plus c square minus ab minus bc minus ca, a plus b plus c. Now your LHS is in terms of xyz. So your a is equals to x, b is equals to y, and c is equals to z. But your RHS is not exactly the same. Here you have x plus y plus z, which is a plus b plus c term here. But this is not the term which is required. There's a 1/2 and this one. So I'm rewriting this equation to prove, to verify x cube plus y cube plus z cube minus 3xyz is equals to 1 by 2 x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. So here you have to modify this so that you have this value and you have 1 by 2. Let's replace these a, b and c in your formula. So your formula becomes x cube plus y cube plus z cube minus 3xyz is equals to x square plus y square plus z square minus xz minus xy minus yz, x plus y plus z. So you have this much, you have this much. All you have to do, in place of this much, you should get 1 by 2 and your last square bracket. So this is x plus y plus z. Taking the second part first. Here you need 1 by 2. So let's multiply, divide. 1 by 2, that means you are multiplying it and dividing it by 2. 2 upon 2. Now you need 1 by 2 outside. So you can take 2 inside. So let's write this something like 1 by 2 into 2 times this whole bracket. So I'm multiplying every term with 2. So 2x square plus 2y square plus 2z square minus 2xz minus 2xy minus 2yz. So what I've done is I've taken care of this 1 by 2 as well. Now all you have to do is rearrange this bracket so that it looks something like this bracket. 1 by 2 x plus y plus z. Now I'm writing 2x square as x square plus x square. X square plus x square plus y square plus y square plus z square plus z square minus 2xz minus 2xy minus 2yz. Means here you have 1 by 2 x plus y plus z as it is, x square, y square and 2xy. This looks something like x square, x minus y whole square, but I'm writing it separately. X square minus 2xy plus y square. Next term, x square minus xz plus z square. Now here you need z minus x. So I'm writing z square first. It can be written as plus z square minus 2xz plus x square. Lastly, you need y minus z. So y square plus z square minus this one. So plus y square minus 2yz plus z square. So 1 by 2 x plus y plus z, and in the second bracket this can be written as x minus y whole square plus this can be written as z minus x whole square. Lastly, we have plus y minus z whole square, which is your RHS, hence verified. So you started with your formula and therefore LHS is equals to RHS, because when you say equals to, your left hand side is exactly this one, which is x cube plus y cube plus z cube minus 3xyz. So you started with the identity that you know and you modify that identity to get this value. This is also an identity and this is also an identity. First identity is in terms of ABC, second in XYZ. Next, 13th. If x plus y plus z is equals to 0, show that this value. Now here also we'll use that big formula that we did in two of the previous questions. X cube plus y cube plus z cube minus 3xyz is equals to first bracket x plus y plus z, second bracket x square plus y square plus z square minus xy minus yz minus xz. So it's given that this value is equals to 0. So if we play is here 0, it is 0 multiplied by this whole bracket and your answer is 0. So your x cube plus y cube plus z cube minus 3xyz is equals to 0. Taking this value on the right hand side, you get x cube plus y cube plus z cube is equals to 3xyz. Hence proved. Next, without actually calculating the cubes, find the values of each of the following. Now, you are not supposed to calculate the cubes, but it is written in the format of a cube plus b cube plus c cube. Now, what is a cube plus b cube plus c cube? We know that a cube plus b cube plus c cube is that whole big formula, the formula that we just did in the previous question. We'll write the formula again. X cube plus y cube plus z cube minus 3xyz is equals to x plus y plus z, x square plus y square plus z square minus xy minus yz minus xz. Now, if you observe the values in your first part, you're supposed to calculate minus 12 whole cube plus 7 cube plus 5 cube. This is your first question, first value that you have to calculate. This is something like x cube plus y cube plus z cube. So if you relate this with your x cube plus y cube plus z cube, you get x is equals to minus 12, y is equals to 7, and z is equals to 5. Now your RHS case has a factor x plus y plus z. If you add these three values, x plus y plus z, you get minus 12 plus 7 plus 5, which is equals to 0. Now, from the previous question, we understood that if x plus y plus z is equals to 0, your right-hand side disappears. That means this whole thing becomes 0 because x plus y plus z is equals to 0, which means your formula gets modified into a new formula. When, or you can write here since x plus y plus z is equals to 0, therefore, this is your equation 1. Equation 1 becomes x cube plus y cube plus z cube is equals to, I'm taking this on the right hand side, you have 3xyz. So now, applying xyz values in this equation, we get minus 12 whole cube plus 7 cube plus 5 cube is equals to 3 times minus 12, 7, 5. This is equals to minus, you'll have to multiply to get 1260. Next. And the second part as well. Second part that you have to calculate is 28 cube plus minus 15 whole cube plus minus 13 whole cube. Here also x plus y plus z is equals to, you have x cube plus y cube plus z cube. So x is 28, y is minus 15, and z is minus 13. 28 minus 15 minus 13 is equals to 0. So here also your formula will become this, the reduced form, which will be equal to 28 whole cube minus 15 whole cube plus minus 15 whole cube plus minus 13 whole cube is equals to 3xyz, which is 3 into 28 into minus 15 into minus 13. That's a simple multiplication whose value is 16380. Next, 15th question. Give possible expressions for the length and breadth of each of the following rectangles in which their areas are given. Now, what is given to you? You have to find the possible expressions of length and breadth of a rectangle. So let's draw a rectangle. This rectangle would have a certain length and certain breadth. Now, this length and this breadth are in terms of variables, because the area that is being provided to you is in terms of variables. We will allot them length L and breadth B. We know that area is equals to length into breadth. But area given is equals to 25A square minus 35A plus 12. So what can you do about this? The easiest method for such question would be to factorize, because there's a multiplication of two values. You have a quadratic equation. You know that if you factorize, a quadratic expression or equation can be converted into two factors. One factor out of these would be a length, another would be a breadth. So let's factorize this. Here you have 25A squared. So the coefficient of A squared is not 1. Your A plus B value is equals to 35. And A into B value here is equals to 12 into this value, 25. Whenever you have such a problem, what you should do is, you should try and factorize the middle term. But to do so, you have to need this AB factors. So 12 into 25. 12 into 25. Now, instead of multiplying them, getting a value, and then calculating factors, let's calculate the factors of individual, each of these values. 12 can be written as, this is, I like to do it vertically. So 12 is written as 4 into 3. 4 is 2 into 2 into 3. These are 12 factors. 5 factors are 5 into 5. You have to find two values such that their addition is 35. This is subtraction, means both the signs are negative, both the values that you'll calculate as sign negative, and their multiplication is positive. So two values whose addition is 35 amongst these factors. 5 into 5, 25, and 12. So if you add these two values, you get 37, which is not required. Let's try some other combination. What else can be done? 2 into 2 is 4. 4 into 5 is 20. And 3 into 5 is 15. 15 plus 5 is 35. So your factors are 20 and 15. To recheck, you can factorize 20 into 15. 20 into 15. 20 is 2 into 10. 10 is 2 into 5. 15 is 3 into 5, which are the same values over here. So 12 into 25 will be equal to 20 into 15. Also 20 plus 15 is equals to 35. So this can be written as 25A square minus 20A minus 15A plus 12. Here you can take something common, 5A common. You'll be left with 5A minus 4A. Minus, here you can take 3 common. 3, 5A minus 4. Sorry, it should be 4. These two brackets are same, so they'll be common. 5A minus 4, and you're left with 5A minus 3. So either of these two can be considered as length and the other one breadth. So therefore, length is equals to 5A minus 4 and breadth is equals to 5A minus 3. Here you have to end your answer. You do not have to calculate further because your area was in terms of a variable. Your final answer can also be in terms of a variable. Second part is exactly the same. We'll consider the same length and breadth. Once again, consider the same. This is one is length L and the other one is breadth B. Yeah. The other one is breadth B, and your area LB is equals to 35y square plus 13y minus 12. 35, your A into B is 35 into 12. Your A plus B is equals to 13. This is positive, addition is positive, and here you have a negative sign. Multiplication is negative. Multiplication can be negative only if one of the two factors is negative, and the addition is positive only where the greater value is positive. So the smaller value has to be negative. For the time being, forget that the smaller value is negative. Only concentrate that the subtraction of the two values A and B is to be 13. Okay, so it's not the addition, it's a subtraction, because B being the smaller number will be negative in nature. Now, let's factorize this AB. 35 can be written as 7 into 5, and 12 can be written as 2 into 2 into 3. You have to find subtraction as 13. So 7 into 4, say 28, and 5 into 3 is 15. If you subtract them, you get 30. So your factors are 28 and 15. This is written as 35y square, positive of greater value 28y, negative of smaller value 13y, minus 12. This is equals to, what can be taken common? 7. 7y, 5y plus 4. Here minus, you have 13y. Sorry, 15. You have to write 15. So here you have minus 3 common. 5y plus 4. So you have 5y plus 4 common amongst the two terms, and you're left with 7y minus 3. The background noise is rainfall that I cannot get rid of, so sorry about that. The first part, here in the next question, what are the possible expressions for the dimensions of the cuboids whose volumes are given below? Now, the next question is for cuboids and volume. So, cuboid has length into breadth into height, and it can be drawn something like this. This can be considered as your breadth, this can be considered as your length, and this is your height. Let's name them LB and HB. Length, breadth, and height. Okay, so volume is given as this. We know that from the figure, based on these three variables, your volume is equals to LBH, length into breadth into height for a cuboid. And your given volume is equals to 3x square minus 12x. So if it is 3x square minus 12x, you can take 3x common, you're left with x minus 4. This is LBH, which means here you have 3 first value multiplied by x, second value multiplied by x minus 4. So either of these three values can be considered as length, the other one breadth, and the last one height. Therefore, length is equals to 3 units, b is equals to x units, and height is equals to x minus 4. Since we do not know which one is length, breadth, and height, you can write something like, therefore, the possible dimensions, that is in bracket length, breadth, and height of the given cuboid with volume 3x square minus 12x are, and then 3 comma x comma in bracket x minus 4. Second, again volume is given to you, but we know that volume is equals to LBH. So LBH value will be equals to 12 y square plus 8ky minus 20. Okay, so let's take whatever we can common. Out of these three, 4k can be taken common. What are you left with? 3y square plus 2y minus 5. This can be factorized 3 into 5, and you need the subtracted value as 2 because this is negative, this is positive. So 3 and 5 are factors. 5 is positive, 3 is negative. 4k 3y square plus 5y minus 3y minus 5. This is 4k. Here we have y common, 3y plus 5 minus 1 common, 3y plus 5, which is 4k into y minus 1 into 3y plus 5. Sure, you can take this as length, this is breadth, and 4k as height. Okay, so that, I guess, yeah, that concludes your this exercise. Thank you for watching.